this, just to make sure that we are all on the same level. So this is just that's just me. My name is Gerrit Grunwald. I'm working for Azul as a developer advocate. I'm also running a Java user group in Münster, but this is not really interesting for this session. I'm a developer, and I'm not a security expert, right? So who's the security expert here in the audience? Very good. Who's a developer? There you go. 24th of November 2021, I guess maybe all of you remember this log4shell thing. And when that happened, that made me think. Because I place myself more from the 20th century than from the 21st century. And the software landscape in these days have been totally different, right? So code was self-written and closed source. So it was managed in a repository on a local server or in a drive somewhere and manually built. So no build systems. And it was delivered on hardware by DVDs, USB sticks, even floppy disks and stuff like that. And it ran on closed networks these days, right? And large monolithic systems and connected system you only found in government, banking, and energy providers and stuff like that. So in the end, we had full control over the source code, right? So the vulnerabilities in the 20th century also have been different because it was more or less password hacking and cracking. Computer viruses started spreading via floppy disks and USB sticks and stuff like that. And it was the early days of internet hacking, right? So but time flies and we're in the 21st century and things look totally different these days. So we have a lot of open source software that is used. It's distributed source code management systems. We have automated build systems, CI/CD. They are hosted in artifact repositories, running in public networks, accessible via browsers or APIs, and everything is connected, right? So we have a complete software supply chain these days. That means we don't have the full control over the source code anymore. That's a big difference. And the vulnerabilities also changed dramatically. So the biggest issue these days is more or less social engineering. If you never heard about it, then look it up and look up SIM swapping. If you don't know it, then this is really shocking. Then you ask yourself about two-factor authentication. Who knows what SIM swapping is? Okay, the rest, look it up. It's fascinating. We have malware and ransomware everywhere, spread via email, websites, even short messages on your phone. Everything that is connected will be hacked, and malicious code spreading is way easier than it was ever before. So the whole software supply chain is target of attacks. But before we start, we have to take a look at some definitions, because this is probably something you will stumble upon. First of all, there is this thing called CWE, which is Common Weakness Enumeration. And you will find a lot of these QR codes here. You don't have to take screenshots now because I will provide the slides. This is a community-developed list of software and hardware weakness types. And if you find issues like vulnerabilities, you often find these CWE codes along with them. And then you can look them up. You see there is the URL, cwemetri.org. There you can look up the CWEs, sorry. The next thing is, we have these issues, right, these vulnerabilities, and somehow we need to keep track of them. And for that reason, you will find the so-called NVD, which is the National Vulnerability Database. And this is a US government repository of standards-based vulnerability management data represented by this SCAP protocol. And you will find it under the nvd.nis.gov. This is, even if it's in the US, this is the international database that keeps track of so-called vulnerabilities, right? So if you would like to look up something, this is the place to go. The next thing, and this is more or less the most important one, is the CVE, Common Vulnerability and Exposure. And this is probably something you heard before. So this is the CVE program mission is to identify, define, and catalog publicly disclosed cybersecurity vulnerabilities. That means every vulnerability that is out there, which will be stored in the NVD, in this database, gets a CVE, right? Which is, it is a code that defines this or describes this vulnerability. For an example, we have the log4shell that we all know under this name. Security experts know it under this name, right? So this is CVE 2021-44228, right? Under this code, you can find it in the NVD. And you will find something like this. You don't have to read through it. You see it's a lot of text. It's more or less the versions that have been affected of log4j. Then the vulnerability itself. So what is the vulnerability with this log4j thing? And then also a description of different versions, stuff that happened, and so on. And you will find that for every vulnerability out there that is known. And if there's a new one, then it will be checked, and then it can become part of the NVD. Now we have the database, and we have the vulnerabilities. Somehow we need to score them, right? So there might be vulnerabilities that are really critical, and then there might be something that is, oh, okay, it's a vulnerability, but it's not really critical. So we need some kind of a scoring system, which is the CVSS, the Common Vulnerability Severity Score. And to make it more complex, there's not only one, but there are two. And this is the old version. It's the CVSS 2.0. And you see there was only low, medium, and high, right? And the low started with 0. And that's a little bit bad, because that means even if there is no vulnerability, really, it has a vulnerability score of 0. Which means if you just have the text, it would say, oh, there's a low vulnerability, even if there is nothing. Right? So this is, they figured out that it doesn't really make sense, and they came up with a new scoring system, which is this one, right? So if there is nothing, then it's none. And then there's low, medium, high, and critical. And they changed it, not really the scoring, but there is a new version that came out November last year, which is CVSS 4.0. But this contains more details. So it changed stuff in the details, which is not really that important for us, but for security experts, probably. So, and if we take a look at the log4shell thing, then you see the CVSS score 2.0 was 9.3, and for the 3.1, it's 10. So it's critical. This is the highest possible score you can get. And I mentioned both of them because you will find both of them for vulnerabilities, not only one. The older ones only contain the 2.0 scoring, and the new ones contain both. So you will find both scores. So that means the score alone doesn't really tell you anything if you don't know which scoring system they used, right? So you have to look that up. And you can see that it's here in the NVD NIST Gov, and then you see vulnerability detail, and then you see the link to the CVE. That's how it works. Okay, so that have been the facts. The question is Java secure? Who's using Java, by the way, here? Who's doing Kotlin? Ruby? Groovy? Scala? Okay. So more or less, but everybody's on the JVM. Did you ever ask yourself if the stuff is secure that you download? If it's tested? You download updates, I hope so. You just download it, right? You download and install. Did you scan it before you install it? Who's scanning the JDK when he installs it? Well, that's what I thought. So lucky us, there's the OpenJDK vulnerability group, which is a group of trusted members of the OpenJDK community. So it's a private forum. So that means even if I'm the best known security expert, I can't just say, okay, I would like to be part of it. They choose the people that should be part of the forum. And they receive and review reports of vulnerabilities in the OpenJDK code base. And they collaborate on fixing these issues, coordinate the releases of such fixes, and maintain lists of CVEs patched for each release. Right? So, and it's tracked by CVE components. So it means it's by JDK components. So it's we have the modular JDK. That means a CVE doesn't really attack the whole JDK, but parts in the JDK. And it might happen that you don't even use this part of the JDK. And then that's the reason why we have the tracks, the CVEs by components, because you might not even be affected, right? They discuss OpenJDK security-related issues, but they do not actively test the OpenJDK source code. Right? This is up to the people that build the distributions. Okay, and they come up with these open vulnerability advisories. Who knows what that is? That's shocking. You will find them here. 4 times a year, with every update, there is a new one. And it looks like, for the last one, looks like this. That was this Tuesday. And you can see the vulnerability advisory for that date, and then each version that have been affected and the CVEs, right? And you can click on the CVEs, it will bring you to the database and you can look up the stuff. So you see that here have been some higher ones, like the first 3 ones is 7.4, and this is CVSS 3.1 scoring. So this is high, and it was and you see that the upper one was only affecting JDK 17, not 21, not 11, not 8. So it's these kind of things that you will find in the advisories. That leads me to the Java release cycle, because even if it doesn't really look like important, it is. So this is the old cycle, right? So who remembers Java 6? Who was coding in Java 6 here? Okay. You know how long it took until we got finally JDK 7. And then it took another 3 years before we get JDK 8, right? It was in 2014. And this is the old cadence, and then everything changed, right? So it changed to the new cadence. And nowadays we have lots of releases. Between all these releases, it's always 6 months. And then you see the black ones. This is the long-term support versions. They have longer support. The white ones only have support for 6 months. After this 6 months, you don't get any security updates anymore. So let's say you stick to JDK 13 for what reason ever, you will be at JDK 13.02 and that's it. You won't ever get any security fixes for that version anymore, right? So only for the black ones you get long-term support. That means for JDK 11, for example, it's until 2029. So that means you will get security patches until this day. This means long-term support versions. So you better stick to the black ones in production, right? So the white ones you can use in development to test new features, but in production, please stick to the black ones. The question is, how does this affect security? Well, that's pretty simple. In the old cadence, this have been the number of features per release. And you see JDK 8 was 56 new features. JDK 9, and this is because of the modular system that came, it was 91 features. So if we take a look at the new ones, it looks like this. And you can imagine less features per release means less potential vulnerabilities per release, right? And if you stick to, or if you remember these old days when you came from 6 to 7, sometimes it took a year to really get your production system up to JDK 7 because you have all these new features. You have to test it with the old libraries and so on. It takes forever. This is now way faster and way more secure because it's way easier to test a few features than 56, right? So the release cycle is also something that is important for security. And that leads me to updates, because this is quite interesting. We have 2 different kinds of updates. We have CPU updates, critical patch updates. Who knows what that is? Now that's no wonder, because it's not really publicly available. What it is it's an update that only contains fixes for vulnerabilities and for critical issues. And that's it, nothing more. And then there is a so-called PSU update. Who knows what that is? Who did update his JDK last Tuesday? Come on, nobody. You know that there was a security patch last Tuesday. 21.02, 11.022, and 17.010 came out last Tuesday. You should update your JDKs. And this was a PSU, that's a patch set update. This is what you can download from all the websites, right? So the difference is the PSU contains the CPU plus non-critical fixes, and it also introduces new features, tiny features, not really something big, nothing like Loom or something. But these tiny features can break or can bring new vulnerabilities, right? I have an example for you later on. So if we take a look at 17.02, it came out in January, years ago. Then we see on the top one, we see the PSU. It contains the CPU, and the bottom one is only the CPU. The interesting part is when I show you the next update in April, then you see how this works. The CPU 17.03 is based on the PSU 17.02. It only contains fixes for vulnerabilities in 1702. No new features. Well, the 1703 PSU contains the CPU plus they also add new goodies, right? And the upper one is the stuff that you download from the internet. Because the lower one you can only get from Oracle, Bellsoft, and Azure, and you have to pay for it because this is additional effort that these companies spend to make that work. And then this goes on, right? That means the CPU updates are feature-wise always one step behind the PSU. You have to keep that in mind. The question is, why does it matter? Why do we have CPU updates? Well, there was an update called AU252. That's the old numbering. And this is a PSU, and that led to a problem with Hadoop cluster in Solar. When you installed that one, it didn't work anymore in production. That was the official build that you download from the internet, from Oracle, from Tamarind, from wherever. Tamarind wasn't available, but adopt OpenJDK, for example. But if you stick to CPU U251, right? You see it's just this, the difference between the PSU and CPU numbering in version 8. Then this one was based on the last PSU, 842, and it only contained the bug fixes, the really critical issue fixes. And this one didn't break. Right? So these little features that they added led to the fact that Hadoop cluster and Solar didn't work anymore. So this is the reason why some companies, and I say some because it's not for everyone, but if you run something like a bank, insurance companies, trading companies, or mission critical stuff, you better have a CPU update. This is also the reason why companies pay for Java, because they rely on these things, right? They have additional 3 months to fix bugs. That's the main reason. So if you have, if you don't update your JDK, and if it's true that nobody updated last week, then let me give you an example. If we go from JDK 1700 GA to 17010, which is the latest one today, we start in September 2021. 17.0 came out. Then, 1 month, this is in October, right? It's 1 month later. Already 8 CVEs have been filed for JDK 17. Okay, they have been fixed in 1701. 1702, another 15, and so on. This is additional, right? Additional CVEs with each update that have been fixed in the last one, and so on. You see, this is a lot of CVEs. And this one, the last one from Tuesday, fixed 7 CVEs, 3 critical ones. That means if you today, still on JDK 1700, right, you're open for 61 CVEs in your JDK. Just keep that in mind. That's why I tell you, update your JDK. You might think, I have 1703, it's still okay, it works. Well, there's a lot of security issues in there. That's the reason why we have these updates. And they are for free, update it. So if it ain't broke, don't fix it. Well, I would say if it ain't broke, at least keep it up to date, right? That's the least thing you can do. And that leads me to modular images, or runtime images. Who knows J-Link? Nobody, really. Honestly, who knows J-Link? No one. Okay, that's really interesting. But you know that we have who's running on Java 8 here in production? Okay, yeah, don't be shy, it's okay. Who's running on 11? Okay, 17? And 21, someone? Okay, cool. You know, everybody from 11 till today, this is the modular JDK, right? It came with JDK 9. And with JDK 9, there came a tool that is called J-Link. And the reason for that is, then another question. Who's running a JDK in production? Someone? Who's running a JRE in production? You should run at least a JRE. A JDK is a development kit, right? And the other one is a runtime environment. So the idea is, if you reduce the number of modules in your JDK, you reduce the risk from vulnerabilities, right? So there's a tool called J-Link, which comes with the JDK. It's part since JDK 9. And this you can use to tailor a JDK for your application. And let me give you an example. So you can remove unused modules and this reduces the vulnerability risk. And hackers can't attack what isn't there, right? So I've wrote a little, it's a push notification server for a private project, and I just made a test. So this is all the modules in JDK 21.02, which is the latest JDK. It's 69 modules, right? It's 339 megabytes. If I use a JRE, then it's only 50 modules. Still 150 megabytes. This is just the JDK or the JRE, the runtime environment. If you use JLink and tailor your JDK, then this is the stuff that I really needed for my push notification server. It was 11 modules because my app only used 11 modules from the JDK, and this was 48 megabytes, right? So that means if you compare that, first of all, it's way smaller. The risk for vulnerabilities is really lower. You see, I just have 11 modules compared to 69 modules. Even if there are vulnerabilities for other modules, if I don't use them, I don't care. Right? So you really should use JLink. That makes sense. And that leads me to the software supply chain. It starts with us, the developers, and we use more or less a central repository, Maven Central, to drag in resources when we develop stuff. And then we submit that to our own repositories. And then from there, it goes into the CI/CD build system. This drags in another resources, transient dependencies from the central repository. And then we build containers out of that. We publish that in artifact repositories. This can also go back to the central repository, and we deploy it to production. This is more or less how it could look like, right? This is not, you will find similar diagrams, but this is also something that's quite common. The vulnerabilities are more or less everywhere. All of these red triangles here show you places where hackers can attack the software supply chain. And not only can attack, they do this. And this is not something I made up out of my mind. This is stuff you can find. People can hack your things everywhere. Even if you think, oh, I'm quite sure that nobody will ever hack my repository. This will happen. Your CI/CD build system, no problem for these guys to get in there. Right? All these things, containers can be hacked. It's crazy. So let me give you some facts that I found on the web. So this is, does someone know the Sonar type state of the software chain report? They bring that out from time to time. It's quite interesting because they run Maven Central. They have lots of data that they can check, and they have also security products, so they are interested in that. So they figured out that over the last 3 years, and this is based on March last year, that the software supply chain attacks, the number increased by 742% in 3 years. So you see that people are keen on hacking the software supply chain because they know it's vulnerable. And then there's another one. This is from the National Vulnerability Database. It's a little bit older, but it's the distribution of severity of issues over time. And you see this jump in 2017 where it bumped up. And I don't know why this bumped up, maybe because they recorded more, or I don't know, but you see it's a lot. In 2021, alone, it was 20,142 unique bugs and security vulnerabilities that have been recorded in the NVD. This is really a lot of issues, right? And then there's another thing, which is quite interesting. Who's using Log4j here? Okay. And I talked to Christian Grobmeier, who's one of the maintainers. And this is based on October last year. And he told me that in October last year, still 20% of all downloads of Log4j have been downloading the wrong version that was vulnerable, even if it's fixed for 21 months. So you can download the secure version, but people download the insecure version because they are lazy. They don't update their dependencies. They don't check something. They don't scan it, right? And that's crazy. So it's user laziness also leads to problems. So you open the door for vulnerabilities just because you never really check your dependencies, or you check your build scripts where you have maybe hard-coded dependencies or whatever. Another thing that I found, it's again from the Sonar Type State of Software chain report, that they figured out that 6 out of 7 project vulnerabilities coming from transitive dependencies. And that's really not really surprising, right? So you have your project. You depend on whatever library. You can scan that, it's fine. But this library depends on other libraries. And these libraries might depend on, again, other libraries. You can't check them all. So that means you think you are safe, but you are not, if you don't scan, right? So and this data, it's really based on hard data. I mean, they run Maven Central. They have lots of code to check, and they know that this is a problem. This is something that I found in a Synopsys OSS security and risk analysis report. It's at least one vulnerability was found in 84% of all the databases, code bases that they scanned. And from this 84%, 48% contained high-risk vulnerabilities. That means a lot of the code contains high-risk vulnerabilities, which could be really critical. And then another thing that is quite interesting is open source was used in 96% of all these code bases, and 76% of these 96% have been open source itself. So who's using open source here in his projects? Probably all of you, right? We all do. Let's talk about open source. You know this? You don't have to read through it. I just show you the important parts. There's a license, right? It is provided as is, without warranty of any kind. In no event shall the authors or copyright holders be liable for any claim, damages, or other liability. Usually in open source projects, you find something like this. Did you ever read that and understand it? Because what does it mean? It means I owe you nothing. You can use my code, but if it fails, your problem. You can't blame these open source guys for creating code. You use it for free, but you are responsible for checking it, right? So because it's like that. It's like Log4j. Everybody's using Log4j because it's so nice. But it's maintained by a handful of people. And you use that in all your projects. You never pay for it, right? So you have to keep in mind that open source maintainers are not suppliers, right? So you don't have any business relationship with them. There are no contracts or something. And in the end, if you use their code, it's up to you to make sure that it's secure. It's not their fault, it's yours. Right? This is important because lots of our software today is based on open source. We just take these libraries and use them because they are so fine and they work so great. But if something fails, people start blaming, oh, how could that happen? Well, you can check that, right? It's not up to the open source. And they tell you in the license that they are not reliable for this kind of stuff. So you have to make sure if you use open source software, if you really understand the license. So what can we do? Well, there is something called shift left. Who knows that? You probably heard about it. So if we take a look at the software supply chain, then usually we have the dev on the left side, and we have the ops on the right side. And in the past, the ops was responsible for security. That's the way it was. And shift left means that we as the developers should be more aware about security. That's the main movement of shift left. That's what it means. And we have DevOps, which became DevSecOps in the meantime. And if we take a look at this DevOps loop, then it starts with planning, coding, building, then we have release, and then we're starting with the ops part, which is deploying, operate, monitor, and then it goes back to planning. The question is, where's security here? Security is everywhere. There's not one part that is responsible for security. Security applies to all of these parts in software development, right? That means DevSecOps. So shift left, yes, but also validate right. I will come to that, what that means. So first of all, and I told you already, you have to update your JDK. Very important. You saw all the open CVEs that you collect over time. And there are tools to do that. So who knows SDK Man? So this is probably all Linux and Mac users because it's not available for Windows. For Windows, there's something like Chocolati, I think is the tool that can do the same. So it supports many JDK distributions, and it's a command line tool. It can download and install JDKs and update it for you. This is the main thing behind SDK Man. It can do lots of other things too, but it can do it for JDKs, right? So which is cool. Shameless plug, I wrote my own tool because I was lazy. This is called JDKmon. It's open source and free. And what it does, it supports all JDKs that I know. It's more than 20, also GraalVM and JavaFX stuff. And it downloads the JDKs. You have to install them on your own. And it's a taskbar application. It's for Windows, Linux, and Mac because it's a Java application. So, and it shows you CVEs in OpenJDK, right? So this is how it looks like. When you start it, you have a little icon in the menu bar. You can click it, then this window will open. It shows you all the installed JDKs in your machine. It tells you the versions that you have installed. And if there is a new one, you see there's this arrow says, oh, there's a new version. You should use that one. And you see the red box here, this one. And that said, there's a problem. You can click on the box, and then it will show you the CVEs for this JDK that are known by the NVD, right? So, like I said, I wrote this tool because I was too lazy to always check the websites for updates. And this tool tells me even when there is the next update, when there is the next release, right? So I can always see, okay, next update is tomorrow or in 50 days or something. Another thing that you can use is static code analysis. So what is it, first of all? I mean, usually it's part of a code review, and it identifies vulnerabilities in source code. And that means at the implementation phase, it's very inexpensive, right? Because you can adjust it easily. While you're coding, it will tell you there's a problem, right? So the standalone tools and IDE plugins. And if you go to the NIST.gov website, they give you a list of static analysis tools, and they say it's not the list. This is just a list. If you have no idea what it is, you can check out these tools. And you see there are free ones, there are ones you have to pay for, and this says nothing about the quality of the tools. So there's one thing, for example, find security bugs. Does someone know that? Or find bugs, maybe? This is the older one. Yeah, this is the newer one. It's called find security bugs. And it's free of charge. You can just use it. And it extends spot bugs. And spot bugs is the successor to find bugs. And it has more than 400 bug patterns. And it's a plugin for IDEs usually. And then the next thing that you should take a look at is vulnerability scanners. That's quite important. So what is it? So they detect vulnerabilities not only at source code level, but they can also scan using a database. They can probe code for common flaws. They can figure out misconfigurations. They can help you using artifacts only from reliable sources, right? So if you use whatever module that you download from whatever website, these tools can tell you, you know what, this website is not secure. You better download it from there, right? Stuff like this. It helps you to only get the latest secure version because they know which version is secure. They monitor appearance of new packages, and with fixed vulnerabilities, they can update your dependencies automatically if you like. And how they work is, and where they can scan and fix your source code. They can scan, fix, and monitor your repository, your CI/CD build system, artifacts, and they can also scan production. Who's scanning here at all? Does someone use a vulnerability scanner? You should. It's really, this is not a joke. It's really important. And if we would like to know how it works in production, we have to take a short look at the JVM. Because the JVM has all these different kinds of modules inside, or parts, and it also comes with the instrumentation API. It means the JVM itself is an API. And to that API, you can attach a so-called Java agent, right? And this agent can add a callback to the class loading subsystem. And that means every time the JVM is loading a class, it can call the agent and tell, I loaded this class. And then the agent can look it up and say, oh, this class is from whatever library and it is vulnerable or not, right? But all the available agents these days come at least with a performance overhead of 10% or more. That's the reason why companies don't use scanning in production, because it brings down the performance. That means if you would like to have the same performance, you have to pay for 10%, which is a lot, right? So we have different vulnerability scanners available. We have one. Then there's Black Duck, which is quite well known, X-Ray, Sneak, Sonar Cube, Trivi, and others. So if we take a look at Sneakcode, for example, there's a free and paid version, and they support more than 9 languages, and they have a developer-first approach. It's for us. It's not for the ops guys, right? It's for developers, which is really nice. They have a standalone version, and they have an IDE plugin, and they stop at CI/CD integration. So they don't have production scanning for the reason that I told you, because of the agent of the overhead. So they don't do it. You only can scan everything up to CI/CD. And this is how it looks like. This is just one example. They tell you where's the problem and what is the problem. This is just if they do source code scanning, right? So they have all these other tools too. Then there is Sonar Cube. It's very similar, even more powerful. Again, free and paid. They have more than 30 languages that they support and more than 4,800 analysis rules. And there's also a standalone version. There's a plugin available. And again, they stop at CI/CD. They don't do production scanning because it brings down performance. So, and this is, you don't have to read it. Important, it's only that they tell you where's the problem, what is the problem, and why. So again, same thing. This is source code scanning, right, at development time. Then we have our own vulnerability detection, which is, it only runs in production. We don't do anything else. And we run only on the JVM. That means all the languages that run on the JVM can use this vulnerability scanner. We have fewer false positives. We do also code inventory. That means this scanner can tell you what code was used by your application. You might ask yourself, okay, why is it interesting? If you have an old code base, then it might happen that you're not sure if all the code is really used in production because it's so old. But you maintain it every time to make sure everything's up to date, right? We can tell you, for example, if specific parts of the code never have been used in the last 6 months, that means you maybe can get rid of it, right? That's the idea behind it. And it's no Java agent because it's in the JVM itself. So, and what we can tell you is, we can tell you where's the problem, right? So for example, here, the libraries, we can tell you the vulnerability scores. And now the interesting part is, because it's in the JVM, we can tell you if you use it or not in production. So that means you might have a transient dependency on log4j in whatever library, which is vulnerable. Then we tell you the version that you use is vulnerable, but you never used it because the JVM never loaded the class, right? So this is the difference in, if you have CI/CD scanning, they can only do guessing because they can just scan what is there, the jar files. We can tell you if you really use it, right? And that's what I mean with the validate write thing. So a secure software supply chain could look like this. We start in development, and we have these different third-party libraries like Spring or Log4j, and then there is even complete software like Cassandra or Kafka or Elasticsearch. These tools run on Java. Their users often don't even know that they use Java. So it's even more important to have something that scans in production while these tools are running, because they use Java, and if it's vulnerable, they have no idea, right? So you can use in development, for example, Sneak, Coverty, Contrast, or the other tools that I mentioned. The same for CI/CD. Containers, there are scanners for containers like Anchor, Aqua, and in production you could use Azure, for example, to make sure that everything is secure. And this is shift left, right? This is validate right, because we can validate that the guessing from the CI/CD scanners have been correct in production. So the takeaway from this session should be follow an automated patch schedule. Usually it's in line with the OpenJDK distributions, like the stuff that I showed you last week, or this Tuesday was the latest update. So just update your software in these same cycles. Makes sense. You should automate the application packaging with JLink. You really should think about it. You save time, you save space, and it's more secure. And watch for CVEs and libraries, right? So you can automate the updates in line with the OpenJDK quarterly patch schedules and stuff. So it's not really so hard. And use vulnerability scanners. I mean, you can even test it for free. Sneak and Sonar Cube, you can even use it for free, just in a reduced version. But it's a good start if you don't use it at all. So do you need to be a security expert? No. But you need to be aware. Right? This is the most important takeaway. And with this, I say stay secure. And if we have questions, we have still 3.5 minutes. Any questions?
How do you get the data out of the production vulnerability scanner?
Yeah, so how it works in production is the JVM loads all the classes, right? And then we have a specific tool that you can install in your infrastructure. And the JVM from time to time talks to the tool and just tells the tool what classes it loaded. And then this tool goes through your firewall out to our database and checks against the database. And then we give you a web interface. You can even integrate it in your own software if you like. But this is how it works.
And what about the issues, for example, that came up from 8.2.4.2 instead of 8.2.4.1, for example, and Solar issues and so on, instead of check all the forms and so and figured out if there's some problems to update these versions. Is there a tool to handle that? So how can we do?
I think you mean the stuff with the 8U252 and
yeah. Exactly.
So the problem is that if you would like to have secure patches, you have to pay for it. This is the first thing you have to do. There's no tool that tells you, oh, by the way, the patch, this one where you have to pay for it doesn't contain the issue. So there's, at least I don't know about some tool like this. Because usually they do these tests, right? It was unexpected that this happened with the 8U252. But it's not the only time that it happened. We have lots of these things because we also built our JDKs. Sometimes it's hours before the official release, someone come up with, there is a security patch. And then suddenly the whole thing has to be shifted and fixed, so which is sometimes really hard. So there's no tool that checks all these things. Because usually that suddenly appears in production and then people cry and say, it breaks, and then we need a new security patch for this kind of stuff. But there's unfortunately no tool that helps you figuring out if you are really affected by this thing or not.
Thank you.
What about Docker images? You know how they are aligned with the security path, and the other things is about other things other than OpenJDK, for example, Temorin.
There are scanners for Docker images too. So most of these tools that I mentioned also scan Docker images. The problem is that if you create your Docker image, what do you usually do? You use a base image, right? And the base image, you have no idea. It comes with a JDK inside most of the times. There's one more reason to use JLink to create your own Docker images. Because there's no way to make sure that the Docker image that you get is secure. You just trust it. All this stuff that we do is trust. We trust all these systems, right? Like I said, you download the JDK from a website, you trust that it's secure, but you have no idea. Nobody really scans that. And the same goes with all the libraries. You just say, oh, there's a new dependency. Yes, I use it, of course. You never really check that. And with the Docker image, it's exactly the same. You just download the Docker image and trust it's secure. But there is no guarantee. So this is one more reason why if you create with JLink your own stuff, you can make sure that your Docker images contain only the JDK that you really created for your application. And I think we run out of time. So I will be outside. If you have any more questions, we can check it there. Thanks.